Hello friends, myself Mahajan presenting my video on Gauss Seidel method. Let us solve the problem. Solved by Gauss Seidel method. Equations are 10x plus y plus z is equals to 18.141. Second, x plus y plus 10z is equals to 38.139. And the third, x plus 10y plus z is equals to 28.140. Here we have three equations in three unknowns. Unknowns are x, y, z, and we require to apply Gauss Seidel method. Therefore, first of all, we check the condition for convergence, whether it is satisfied or not. Absolute value of 10 must be greater than sum of the absolute value of the remaining. It is 1 plus mod of 1. Therefore, absolute value of 10 is 10 is greater than 1 plus 1, 2. Therefore, condition is satisfied here. We check for the second diagonal element is 1, mod of 1 must be greater than sum of the remaining absolute value of 1 and absolute value of 10. Here absolute value of 1 is 1 and sum of these two absolute values is 1 plus 10, 11, which is not greater than 1. Therefore, here the condition is not satisfied for second equation. And in third, again absolute value of 1 must be greater than sum of the remaining absolute values. It is 1 plus 10, absolute value of 1 plus absolute value of 10. Again not greater than, and therefore condition is not satisfied. And as condition is not satisfied, we have to rearrange the equation to satisfy that. As it is no change, therefore it is 10x plus y plus z is equals to 18.141, and this equation 2 and equation 3 we have to interchange so that condition of convergence is satisfied. Therefore, this we consider as second equation, x plus 10y plus z is equals to 28.140, and second as third, it is x plus y plus 10z is equals to 38.139. Here absolute value of 10 is greater than 1 plus 1, that is 2. Second, absolute value of 10 is greater than sum of the absolute values of remaining 1 plus 1, 2, 10 greater than 2. And here absolute value of 10 is greater than sum of the remaining, that is absolute value of 1 plus absolute value of 1, that is 10 is greater than 2. Here the condition of convergence is satisfied. Condition of convergence is satisfied. And it is satisfied, we have to solve the equation for the highest coefficient. Means first we have to solve for x, second for y, and third for z. We get from first equation we have x is equal to 1 by 10 times, it is 18.141 minus y minus z, and we call this as equation 1. Solving it for second for y, we get y is equal to again 1 by 10 times 28.140 minus x minus z. We call this equation 2. And then solving it for z, we get z is equals to 1 by 10 times 38.139 minus x minus y. We call this equation third. Then we have to apply that iterative procedure using this equation 1, 2, 3. Initially we have to substitute y and z as 0 to get the first approximation. Fix your calci for 3 significant digits. So step 1, we have to use equation number 1 to get first approximation for x as 1 by 10. We have to put y and z as 0, therefore it is 18.141 minus 0 minus 0. 18.141 divided by 10, we get that value as 1.814. That value we put here in the table in the first row, 1.814. Then using equation 2, we find first approximation for y1. On right hand side we have the two variable x and z. We put latest value of x as 1.814 and z as 0, and therefore we get it is 1 by 10 times 28.140 minus x is 1.814 and minus z is 0. And if you perform that by calci, we get that value as is 28.140 minus 1.814 and divided by 10, we get that value as 2.633. 2.633. And therefore if we perform it, we are getting that value as 2.633. Then substituting these two values here in equation 3 to get first approximation for z as again 1 by 10 times 38.139 minus x 1.814 and minus y is 2.633, and therefore if we perform this by calci, we get that value as 38.139 minus 1.814 and minus 2.633 and divided by 10, we get that value as 3.369, and therefore we put that value here 3.369. Here the first step is completed, first iteration is completed. Then we use the same equation once again to get the second approximation for variables. Step 2, iteration number 2. From equation 1 we get x2 as 1 by 10 times 18.141 minus y. The latest value of y is 2.633 and minus z, the value of z is 3.369. And therefore performing this by calci, we get that value as 18.141 minus 2.633 minus 3.369 and divided by 10 or multiplied by 1 by 10. It is 1.214. 1.214. We write down that value here in second row the value of x is 1.214. Then use it here in equation 2 along with the value of z as 3.369. We get y2 as again 1 by 10 times 28.140 minus x is 1.214 and minus z 3.369 and therefore by calci it is 28.140 minus 1.214 minus 3.369 and divided by 10. It is 2.356. We put here 2.356. Okay, this is the value of for y in second step or second iteration. Then using these two values here in equation 3, we get z2 is equals to 1 by 10 times 38.139 minus x is 1.214 and minus z 2.356. Oh sorry, y is 2.356. Performing it by calci, we get 38.139 minus 1.214 minus 2.356 and divided by 10. It is 3.457. 3.457. Value is 3.457. Here the step 2 is completed, iteration 2 is completed. And if you observe the values not equal or nearly equal, therefore we have to go for step number 3. Step number 3, iteration number 3. Once again applying the same three equations, we get x3 is equals to 1 by 10 times 18.141 minus y, latest value of y is 2.356 and minus z, latest value of z is 3.457. Performing it, we get 18.141 minus 2.356 minus 3.457 and multiply by 1 by 10. It is 1.233. 1.233. New value for x. Then use this here in equation 2 along with this value of z. We get y3 as 1 by 10 times 28.140 minus x 1.233 and minus z is 3.457. Simplifying it by calci, 28.140 minus 1.233 minus 3.457 into 1 by 10, we get 2.345. 2.345 2.345 as the new value for y. Then put these two values here in third to get Z3 as 1 by 10 times 38.139 minus x 1.233 minus y, the value of y is 2.345. Simplifying it by calc, every time I am performing the calculation on calculator, you can verify it yourself. 38.139 minus 1.233 minus 2.345 into 1 by 10, 3.456 a difference of 0.001 nearly equal, a difference of more than not nearly equal, and these two values also not nearly equal. Therefore, we have to go for one more step, one more iteration. Step number 4. Again applying this equation 1, 2, 3 with the latest values of x, y, z. Therefore, from equation we get x4 as 1 by 10 times 18.141 minus y is 2.345 and minus z is 3.456, and therefore simplifying it by calc, we get 18.141 minus 2.345 minus 3.456 into 1 by 10, we get 1.234. A new value for x. Then use this with z as 3.456 in equation 2. Therefore, we get y4 as 1 by 10 times 28.140 minus x 1.234 and minus z is 3.456, and simplifying it, we get 28.140 minus 1.234 minus 3.456 into 1 by 10, it is 2.345. We put here. Then using these two values here in equation 3, we get Z4 as 1 by 10 times 38.139 minus x is 1.234 and minus y 2.345 and simplifying it by calci, once again we have 38.139 minus 1.234 minus 2.345 into 1 by 10, we get 3.456. 3.456. And if we observe the values, same values for Z for iteration number 3 and 4 or successive iteration, we have same values. Y is also same, 2.345, 2.345, and for x, difference of 0.001. 0.001 is the difference, means nearly equal. And as we get nearly equal or equal values, we can stop the iterative procedure. Thereby, the final solution is x is equals to 1.234, y is equal to 2.345, and z as 3.456 is x is equal to 1.234, y is equal to 2.345, and z as 3.456. 3.456 is the required solution by Gauss Seidel method. Then we can cross check whether the values are correct or not by substituting that values in the equation, and therefore the first equation is 10x plus y plus z is equals to 18.141. Therefore, we cross check it. 10 into x is 1.234 plus y is 2.345, and z as 3.456. That must be equals to 18.141. Therefore, performing this left hand side, 1.234 into 10 plus 2.345 plus 2.345 plus 3.456, we get 18.141. That value is 18.141, and that is equals to 18.141. First equation is satisfied. Similarly, you cross check yourself for the remaining two equations, second and third. If all the equations are satisfied, then we can say that obtained solution is the correct one. Therefore, this is the technique of Gauss Seidel method to obtain the solution of linear simultaneous equation. In my next video, I will discuss interpolation. What is by interpolation and Lagrange's interpolation formula. If you like my video, please share it as well as subscribe to my channel to get a notification for my new videos. Thank you.